What is up YouTube? Welcome back to another episode on Code with Annie. And continuing our data structures and algorithm series, we're going to take a look at the sorting algorithms that are available to us, and we're going to see an implementation of those algorithms in Java. And today we're going to take a look at this particular algorithm. This I've already spoken about in the time complexity and space complexity video. This I have named it as simple sort, but in reality this kind of a sorting technique is called as bubble sort. Okay. Let me rename this simple sort to the actual name that is called refactor rename, and I'll call this bubble sort. Okay, so bubble sort is a very basic sorting technique in which you take every element in the array, the input array that is given to you, and you compare, starting from the first element, you compare it with all the other elements. And once you find that if a particular, the element that you're looking at, that is if you take I equal to 0, the first element, for example 1 in this case, you compare it against 12, 3, 9, 31, and then you see if 1 is greater than any of these. If it is not greater, you let it remain in the same place. Okay, suppose the next element that you take will be 12, so I is equal to 1 will be 12, and you will compare 12 from 3, 9 and 31. Okay, so that's how the algorithm works, right? It starts from I equal to 0 and it compares, and then you go I plus 1, then you start comparing every element, and then you see if 12 is greater than 3, it is, then automatically you will swap 3 and 12, and then you will continue looking at 12 to see if it is greater than any other element here. 12 is greater than 9, again you will swap 9 and 12's position, and then you will see if 12 is greater than 31, it is not, therefore you leave it be, and your iteration ends here. Again I will be incremented to the next value, and whatever is the sorted array, whatever is the value next there, it will again be compared against the remaining elements of the array. So this goes on until you reach the end of the array. So if you look at it, it's a fairly straightforward technique of comparison, and it takes O of n square time complexity. We have already calculated this when I was explaining the video on time complexity, and it is O of n square because there are two for loops and you do a comparison between all the elements, therefore it takes n square. And for very large input sizes this becomes slightly slower because you do comparison at every stage, right? And suppose if this is a descending array and you are going to sort it in ascending, then it's going to be taking a lot of time if it's a very large array. Okay, because there'll be comparison at every single step. Now the space complexity of this algorithm is nothing but O of n, as I mentioned, right? And space complexity, if you look at the previous video, I have explained that it is nothing but the space taken by the input plus the auxiliary space, an auxiliary space being the space that is taken by the variables other than the input that are used here. In this case we are using only a temp variable, and this temp variable keeps on getting replaced again and again in every sorting for loop, and this takes a constant space of O of 1. Therefore the space complexity is nothing but the input array, which is O of n because there are n elements in the array, plus the auxiliary temp variable that you have here, auxiliary space, is O of 1, and O of n plus O of 1 is approximately O of n. Therefore the space complexity is O of n, and we'll write it down for bubble sort time complexity is equal to O of n square, and space complexity equal to O of n, and I'll also write the auxiliary space equal to O of 1. Okay, so keep these things in mind, and this is one of the straightforward and simple sorting techniques. The other techniques that we'll start looking at from the next videos will be a little more complex, and they will also have a lesser time complexity, but they may have more space complexity than this kind of an in-place sorting technique. Okay, this is also an in-place sorting because you're using the same array and you're sorting on the same array. You're not instantiating or putting it in a different array or a list. So this is called as in-place sorting technique. So bubble sort is an in-place sorting technique. All right, so that's it for this particular video. This is quite brief because I have the algorithm already written, but for the subsequent explanations in other videos, the videos might stretch a little bit because the explanations might take a little more time. Sometimes I may even divide the explanations into 2 videos for your clear understanding. So if you do like this video, hit the like button, subscribe to Code with Ani if you haven't already. I will see you guys in the next one. Bye bye.